Hello, welcome to another episode of Neural Networking with Ketan. Today we will be having insightful conversation with a seasoned AI practitioner Debarag Banerjee on how enterprises can go about their AI Gen AI strategy, use cases, implementations, and the challenges that come along. Hi Debarag, again welcome to the Neural Networking with Ketan. Thanks for taking time and spending a Saturday morning with us discussing about your passion for data and AI. Debrag, a veteran of AIML industry with over 25 years of experience, Debrag's journey spans the evolution of AI from its early days to today's powerful applications. He's not just a leader, but an innovator with over 15 US patents under his belt. But his passion goes beyond technical expertise. Debrag is a people person who thrives in building and empowering teams. From startups to corporate giants, Debrag's work has led to transformative projects that have generated over $1 billion in value. I am thrilled to have Debrag here today to share his insights and experiences.
Thank you, Ketan, and thank you for inviting me. Glad
So
to be here.
let's straight go ahead. I know you're sipping your coffee, and it's the discussion that we are going to have. So let's directly move into our questions, and the idea is simple that we will be trying to learn from you and from your experiences and shoot you some rapid fire questions to see what we get out of you. Yeah. So the first one goes like, what excites you most about the potential of Gen AI? Because we are seeing, what we are observing is a large Gen AI wave from last 1.5 year with ChatGPT also coming into picture. And where do you see this technology evolving in the next few years?
Right. So Gen AI has been in the cooking for a very long time. It just feels like it sprung up on the world pretty soon, right? And what has happened is so AI has gone through its cycle of being a predictive technology, being something that you use for estimations, and then going out of the bounds of structured data into unstructured domain. And I think it was by now almost 7, 8 years ago that people figured out how to use it in a generative adversarial network GAN methodology. And then, of course, about what is it, 7 years ago, the addition paper came out and has taken off from there. So going forward, in the next few years, I think there are a few things that will happen. Today's generative technologies are of course in the early stages of maturing, where you can see it almost like, yeah, it surprises us. It makes us feel like there are certain benchmarks where it's doing almost as good as a human. Where it's still lacking is its understanding of the underlying physics of the underlying world models. And there are works from various quarters where people are trying to incorporate those world model emerging capabilities. So I think that is going to come together. The other thing that I'm seeing happening is, while in the first few months, years, it was more a race towards bigger and bigger models with higher and higher number of parameters. Now people are beginning to realize that actually smaller models with better fine tuning either equally perform or outperform bigger models, and there are various reasons for that. So while earlier there was this view that there would be one model to rule them all, and everybody was trying to build the biggest LLM possible, It's now realized that ultimately there isn't enough data in the world to quite do that. So this trend towards more specialized AIs is going to evolve. And if you think about it from the perspective of the of the of the way we think about AI as replacing human intelligence, there isn't like one all-knowing human in the world. There are people specialized in certain things. A novelist is great at writing a novel, while a doctor is great at writing
Right.
prescriptions, right? So they're not going to be done by the same AI going forward. So that's one trend I see. The other, of course, is the gift of Moore's law will continue to be giving. NVIDIA and others will probably come up with better and better chips that will make these systems a lot more real time. While large models are already being used for offline generative functions. When it comes to hard conversational latencies like this, they are close, but that last gap still needs to be closed. So I do see some attention over the next few years paid to hard real time latencies. So yeah.
Yes, I think that was a lot of material to digest even for the audience and me both. I think you spoke about a lot of things. So just summarizing, I guess you spoke about the billion parameters, the large language model, the race that everyone was or is trying to build the largest large language model, but at the same time, people are now understanding that you can actually build smaller language models that can be used for solving the business use cases. And there is always this angle of the doctor versus the novelist that you talked about. So I think very what you say, very happening space, Gen AI, and I guess we are also excited and thrilled as an industry to see how and where it is gonna end, or maybe in next 10 years, see that where it takes us.
It won't end. It's only the
Yeah.
beginning.
Yes, yes. I think we geeks sometimes are looking at Star Trek. So I see that there is always a journey that
Yeah.
you take. So just taking that analogy and correlation of Star Trek, I think it's only the beginning, as we can see. So this, then comes to the next point that I'm sure throughout your work with AI in general, you must have encountered various applications. So I just wanted to ask you, can you share the top three most impactful AI use cases you have come across and how they are transforming specific industries? Because I feel that this is identification of the use cases and calculation of the return on investment is something that the enterprises are trying to understand about AI. So some insights about this would be very helpful.
Yeah, sure. Let me first start with what I'm doing today. I work for this company called Presto, and we are building an AI bot, so to say, a voice conversational AI bot that would that already takes orders in the drive-through lanes of fast food restaurants. If you think about the experience today, anyway, you pull up to a voice box and say, "Hey, I want this kind of burger," and there's a guy inside who asks,
Yes.
who you don't even see, by the way, who asks, do you want fries with that? Want to make it a large combo, and so on and so forth, right? And that conversation happens, and after that, this guy puts an order into the system, and then then of course somebody cooks it, and you pick it up and pay for it. Now, this piece, the actual voice piece of handling the conversation the right way, fast and accurately, and placing the order. this piece is something that we are trying to automate with AI. We already have a product, and it's improving leaps and bounds, and it's already deployed in quite a few restaurants. And this is a classic example where this concept of AI actually replacing the need for a human to do a fairly boring, repetitive tasks, which kind of distracts them from what they might otherwise do and do better, which is to actually cook the food or something like that. So this is a classic example of that. So, and I see this kind of voice AI bots are probably going to proliferate in many various parts of the industry. It's only the beginning. So this is the latest. Specifically about Gen AI, I guess there's AI in general, which has actually evolved and made some huge contributions in the rest of the industry. But if we talk about Gen AI, if I want to now go back to like the first Gen AI application that I built, it was actually for a company in India called Myntra, which is part of Flipkart now, majorly owned by Walmart.
Yes.
We were the first ones to ask the question that, hey, for fast fashion designs, where essentially you are trying to pick up trends and then generating new designs that basically follow that trend. So let us say, some kind of a stripes and florals or whatever started trending. Can you pick up, and then can you actually have the AI generate a design which is not a copy of anything that is out there, but falls in the same genre? So this was actually we started even before the attention paper. So we started with more or less regular GANs, and then later moved into attention GANs, and we could actually prove that this could be done where at least generated designs to a point where they can serve as inspirations to actual human designers to take them forward could be done, and were some commercially successful. We actually launched brands that were more profitable compared to brands by human designers, and it actually made money. So this is to my knowledge, this is the first time ever that anybody used generative AI to design fashion in a commercially successful way in the fashion industry. You asked for three, so I'll give you one more example. This is probably by now it's now a little more well adopted, but let's say a year and a half ago, things were still in their early phases. So when you have product support, especially specialized product support, typically you need to ask a human when something goes wrong. So, for example, I consulted for a company called for a large network equipment company, and they had all of these different Wi-Fi routers and switches and so on and so forth. And if things went wrong, their default support was somebody emails or calls a human. Now we put a chatbot in place, and the user of that equipment on the other side would typically be, let us say, an enterprise IT professional who type that, here's my Wi-Fi router, and I see these 3 LEDs blinking or whatever. And then normally somebody would have to go through thousands and thousands of pages of document to figure out, oh, this is the reason why it's doing what it is doing. Instead, we used a RAG methodology to figure out the relevant sections where the answers to that particular question would lie for that particular equipment, and then an LLM that summarize it up and deliver the answer in a way where it is very easily understandable, but at the same time has all the bells and whistles to make sure that that answer is also accurate enough. Meaning, it does not just hallucinate up by learning from similar things it might have learned from its training data of what to do with thinking LEDs. So this was quite successful, and this company is probably far up on Gartner's Magic Quadrant because of those AI empowered network equipment operations. So yeah, so this is by the way, it's not just limited to the network equipment space. In general, similar concepts can be very easily deployed for any specialized product support, where you can make the turnaround time much lower using AI compared to humans. So yeah, three examples.
Yes, I think what you say, the very key takeaway that I see here from what you described is, so there was one use case in fashion you were talking about. There was one use case about the network equipments and how the customer support was enhanced using Gen AI, and there was one more use case which you talked about. So all these three use cases, what I see here, the burger one which you talked about. But what I see here is it has already entered our lives, or it is entering our lives in the day-to-day interactions that people are doing. So that is very encouraging to see. Probably 3 years ago we were not having these use cases which were maybe directly impacting what you say, the user interactions that we were having with the products. So Mantra, you gave a classic example where many Indians are buying what you say, clothes online these days, and I'm sure that's a fascinating use case, as well as the other one with the voice bot that you are working upon. But while building all these use cases with OpenAI, cloud providers, and numerous AI products which are available, the landscape for the technology team can be very overwhelming, and they can get confused that and because you talked about the depth and the breadth of the use cases as well, like it is as different as a voice interface that you talked about versus an e-commerce interface. I'm speaking from an interaction perspective as well, and from a building perspective as well. So so in the voice when we were talking about voice data, then in the e-commerce when we were talking about image data, and then in the network equipment when we were talking about text data. So these three different kinds of data, then there are these many things which are available. So it sometimes can be, what you say, very confusing for someone who is trying to build these use cases. So what advice would you give to listeners on navigating this vast tech ecosystem and finding right AI solutions for their needs?
Yeah, so it is a exponentially exploding ecosystem. There are some of the whenever I go to some of these AI events in the Bay Area or wherever, the number of new startups coming up is just overwhelming. In their not just in their hundreds, but in their thousands, and that's great, right? This blossoming is what you would expect in the early stage of any new technology. And also, when it comes to large language models, I remember only about a couple of years ago, the fear was that OpenAI has got this cornered and they're going to dominate. But I think we're past that point where there are so many other companies coming up with LLMs that are coming neck and neck. Although I must say that having tried a lot of them, there is well the benchmarks are out there, right? So there is still a significant lead that OpenAI maintains. Let's see for how long. Now, that said, it's not always a straightforward decision that okay, we should go with this and not with that, and
Right.
so on. So there are a lot of considerations. So first of all, you asked how does somebody go about doing it, right? Go about understanding. So Hugging Face is a good place to start from, just taking a look at the current leaderboards and stuff like that. The other is most of these agents, you can actually try them out with fairly minimal or sometimes even with a free trial, and try them out with your own use cases, with your own products, with your own with your own agents, and so on and so forth. Um, uh, there is and then you need to think about trade-offs, like what is more important to you. Are you trying to achieve a certain level of accuracy? Are you trying to a certain level of latency, a certain cost point, a certain unit cost, and also think in terms of not just using things with a one-shot prompt or something like that. Think in terms of a full system solution. What are all the pieces that may be needed to make it all work? It's quite possible that you may end up using an LLM from one corner of the world, or one source, and you may use an embedding for from another source. You may be sewing together things in an agent framework where there are different pieces being utilized from different places, and so keep that in mind. Like, for example, you may have a speech recognition engine from one cloud provider, right, or
Right.
one speech recognition endpoint, and you want to choose the one that works best for you, and you may use an LLM from a completely different vendor, right? So keep all of that in mind, and that's the way to build a system. Be up to date. Research every single unit of your solution where you're using a model, and pick the best that fits the three the triangle of accuracy, latency, and cost, and then sew together your own agent that takes advantage of the best picked pieces. And finally, one other thing that I would mention is that never assume that this space is going to remain static. So there would be new emergent players. There would be new versions of currently active players, and so on and so forth. And so the leaderboards may actually fluctuate. So you should build your systems deliberately with enough modularity in the code where you can swap out different endpoints as and when needed, because it's still a very evolving picture. You don't want to get locked up.
Yes, I think you said many important points there, but I think the two highlights which I want to point out here from the answer is the triangle of accuracy, latency, and cost, which you mentioned, and the second thing being the modularity, because today you may have one model which you may have picked up, which is great for the voice application, but then tomorrow, 6 months later, you, since the field is changing so fast, you may have a better model, and now you want to replace the first model with the next one. So you should have the modularity in it, and also it also brings to the point that you need to stay updated to look for the latest and greatest of the things as per your business use case. So that comes to the next question, which is related. So we talked about that again, the very important triangle of accuracy, latency, and cost. But ultimately, when we are working on the triangle, the core of the AI application is the model. So there has been this debate going on between open source versus the licensed AI models which are available. So what, according to you, are the advantages or disadvantages of each approach, particularly regarding data privacy concerns?
So data privacy is something that always comes up, right? And a lot of times, actually, it's often more a artificial concern than it turns out to be a real concern. But that said, there are a few different aspects to it, right? There's certain regions of the world, Europe and other places, who are trying to become their own little, data playing ground, right? They don't want data to leave the borders of Europe. Fine, their choice. In those cases, you want to make sure that the endpoints that are serving are also hosted somewhere that follows those laws. The other part is the enterprise's own similar concerns about how much assurance they have from different providers about whether their data will have any images, any copy that is left, or whether they are only handled during serving time. And quite honestly, most commercial LLM endpoints these days do come with various levels of that assurance. Now, depending on how sensitive of an industry you're in, how how paranoid you want to get with your data, some of that may suffice, some of that may not suffice. And in cases where you really can't leave the bounds of your own data center, let us say, you would be kind of forced to pick LLMs that can be entirely hosted within your own cloud, your own data center, and so on and so forth. Um, so uh, that's the way you want to think about data privacy. Um, now, I think you asked about open source versus license, right? So by definition, if it is a licensed API, you are crossing the bound and going outside and getting your inference and coming back. So you cannot have a licensed model that is also hosted. An open source model, you can create your own image and host it and so on and so forth. It does lock you down. It does limit your ability to pivot to the best and brightest out there. But if you have a truly sensitive data use case, then sometimes that's the only way to go. Now that said, there are a few other intermediate things you could consider, which is when you design your prompt, you could strip anything except for the really relevant pieces of PII, personally identifiable information, before you actually prompt the LLM. And you can do sort of similar things with some intermediate steps as well. So those are things to consider. Yeah.
So one thing also sometimes we look for when we are solving a business use case with an AI model is, for take an example of healthcare. So healthcare has very specific data as per the domain, and you have certain licensed models. For example, in healthcare space, we have the John Snow Labs, where they claim that they have a healthcare LLM model in place, and so but sometimes with the some licensed what you say providers, they sometimes do not reveal on which data the model was trained
Mm-hmm.
upon,
Right.
and so some they show the transparency, but not maybe all of them will show the the transparency,
Yeah.
saying that on which corpus the model was
Yeah.
what specific corpus the model was trained on. Whereas in open source, perhaps that information, if we see from what you say, a low to high transparency, maybe in open source, the transparency is a bit slightly on the higher side as compared to the licensed one. So when we are building the use cases, like I take an example of that healthcare thing. So do you think that it's a good idea at the beginning to build smaller pipelines to test the hypothesis and to see whatever the claim sometimes is of the about the corpus open source versus the licensed AI models? That's a good idea to go from an approach perspective, or you just trust the entities the saying that when they have the licensed model that it was trained on that data, depending upon the level of transparency?
Right. So there are quite a few layers to this. So one is, do you need to know which data it has been trained on versus do you not need to know? There are all of these differing opinions out there about whether certain models are trained with copyrighted data or non-copyrighted data, and so on
Right.
and so forth. Now, the key is whether you as a so there are two different things. One is when you are building the model yourself. The other is when you're using the model. Now, when you're using the model and the model has a certain performance, then does it actually if that model, let us say hypothetically, has been trained on data that is a mixture of open and closed source data, then are you liable, legally, for the use of that inference or not? And as long as contractually you're not liable, it's not a direct liability on you. You may have long-term viability concerns, but then that's the reason that's one of the reasons, but not the most important reason why you may want to have a modular design anyway, where we can swap out endpoints as and when they are better or worse for whatever reason. Um, as far as when you are training your own data, I would probably advise just make sure you have all the rights, or no, and if not, be prepared for consequences.
Right.
Um, the in terms of checking the model, what you really want to check the models for is whether they actually serve your use cases or not. So you want to have your own regression tests, your own end-to-end tests, unit tests, and so on and so forth, where if you're comparing model 1 versus model 2, you have a bag of ground truths and you want to see how well they perform from one versus the other, and have a methodology to actually compare them. And this last point, by the way, is kind of non-trivial when it comes to generative systems, because by definition they have a certain level of creativity in creating the output, right? So two different sentences may be word for word not matching with each other, but semantically they may actually mean the same thing. So by the way, you can look up one of my kind of open source papers out there in archive where I talk about this, where how you want to compare the outputs from a generative system versus a non-generative system are non-trivial. You don't really always want to use n-gram-based comparisons, rather semantic-based comparisons. So anyway, that's a bit of a sidetrack. So coming to the kind of the data privacy versus LLM. Data corpus training versus LLM choice. I'd say focus on two main things. So one is, how does your own use case work on that particular endpoint? Actually, three. So that's one. Number two, make sure you are yourself fine from a legal concern perspective. And the third is, and this is actually becoming more and more important, which is that, like I mentioned, that the world is moving towards specialized models, fine-tuned models. So most likely, at some point of time, especially when you have yourself a significant corpus yourself, you'd want to fine-tune the model that you have. And when you're fine-tuning models, not all models have the same level of fine-tuning leeway. If it is, for example, a closed source model and they expose a fine-tuning API to you, you are limited to the methods that are underneath that API and the signals that you can send through that API. For example, some fine-tuning models, you may not actually be able to plug in your own rewards model. You can only give it prompts and responses. That's how, for example, the 3.5 Turbo fine-tuning API works. While there are other open source techniques or even some closed source techniques where you can compatibly incorporate more advanced fine-tuning methodologies using QLoRa, DPO, a whole bunch of different things. So that last piece is also very important, because at some point of time you will need to fine-tune, and then you want to make sure that you have a fine-tuning strategy in mind. Yeah.
Yes, I think there are a lot of moving pieces to it. So I see that in programming, when we cannot have a deterministic thing, we say it's heuristics. So I will say that it's a combination of many things as of now, so the bottom line is we need to ensure that the right data, the right business use case, and the right model is the triangle that we are trying to achieve. And there is somewhere that what you say, the center of mass for the regulations that we need to be aware of when we are trying to achieve this triangle.
Mm-hmm.
Yes.
Yeah.
Yes.
Please.
So that moves me to the next case that so you see that there are a lot of these enterprises, and they what you say want to apply Gen AI in their business processes or in their use cases, and maybe even for consumer facing use cases. So there is always what you say, this thing that from a strategy perspective. Either you can build a strategy top to bottom, or you start with the bottom and then you go towards the top hierarchy. So what would be your advice to the enterprises about how they can build their Gen AI strategy, and what are these top 3 or 4 things they should keep in mind when they are debating about their Gen AI strategy?
Mhm. Yeah, so I'd say do both, right? First of all, it's important to realize that you need to kind of think differently when you are bringing in a new technique like Gen AI into your processes, right? Now, when you're thinking from top downwards, you have the advantage of looking at the entire set of processes that you have, and knowing where your biggest pain points, cost, friction, ceilings that are preventing you from getting the business to the next level, where your levers are that if you are able to move them will get you the right advantages, and then you have the freedom to design it from an end-to-end perspective, to say that, okay, if we had the right kind of Gen AI modules in this type of places where it would do X, Y, Z, then we can make a change, right? And then after that, almost have kind of I wouldn't call it sponsored research, but sort of like the corporate equivalent of it, where you dedicate teams to try and achieve those those applications, those modules in the right way. So that's how you want. That's where the from a top down. That's where the inspiration comes from, and then how we want to then bring it down as structured problems to then try and get the best solution out. Now, a lot of times, what we're also observing is that there are micro instances, many like hundreds and thousands of areas of micro instances, where people are just adopting Gen AI tools and simply using it then in a way to automate their own work, or to make things faster or better, or with less time. And those are almost impossible to predict, especially for large enterprises. Sitting at a few rungs up, or at a place where you are not actually the person with your keys on the keyboard doing what you're doing. Um, Good examples are using GenAI for coding. It's actually one of the most surprisingly good examples where going from requirements to reasonably good code snippets are becoming quite possible. And I often ask people that, hey, when would somebody write a code chain like a lang chain, right? Where you
Right.
start from, hey, here's my code base, hey, here's a requirement for a new change from a Jira, and here there is a new fix. I mean, there are a few companies trying to do those things, but these are examples where you can't really start from a mandate up and top down, but rather you want to simply open up access to the tools at the node levels, at the grassroots level, and have the practitioners try and use them and find their hacks and publish it internally, externally, whatever, and just be be AI forward, AI first in kind of rehacking the work that they do and get efficient at it. And coding isn't the only example. Like people write meeting minutes, people write technical documentation, even marketing collaterals. The other day I was seeing something where all these fashion companies they were creating catalogs based on, hey, here's a piece of clothing, here's a picture of a model, put them together,
Put them
right?
together.
These are examples of things that you can't really go from top down, but you just give the tools
Right.
to the people who are today toiling and laboring to do these things, and let them just adopt it. And once they adopt, then the thing that you want to do as an enterprise leader is you want to encourage those use cases to bubble up, to have them be internal champions, and be able to essentially take this knowledge and be knowledge leaders within enterprises of how to basically hack your job using Gen AI. So that's another approach that I think traditionally a lot of large enterprises have been slow at doing. Many still are, but the ones who will do it will be more efficient, less costlier, and will have an evolutionary advantage, right?
Right, right, definitely, definitely. But with we always say that with great strategy comes a list of great challenges for adoptions, right? That we always think of. So you mentioned like two, three ways of how they can look at from a strategy perspective. But I am sure that in your experience, when you would have tried to implement these three, four things, you must have seen the challenges from an adoption perspective. So, what were some of the things that you encountered during your journey of the Gen AI strategy when you tried to implement it? What were some of the top two challenges from an adoption perspective, and how could you overcome the hurdles there?
hmm So one is what you touched on earlier, which is about data privacy, or I'd rather say paranoia about data privacy, where traditional IT and security teams inside enterprises, sometimes justifiably, sometimes not, are scared of data leaving the four walls of the enterprise, going to a cloud, getting an inference, and coming back. And in the early days, there was quite a bit of murky space in terms of this data that I'm sending for inference. Is it going to be stored, and is it going to be used for retraining the next version of the model? And if it does get used that way, then are we looking at a potential backdoor that somebody down the line will figure out a new way to hack and crack open and find some confidential information. By and large, I think most licensed API providers are waking up to how to assure again for these kind of concerns, where they have started giving legal assurances and all that of inference data not being used for training, unless you choose otherwise, and so on and so forth. Um, the other part is there is a new genre of let us say attacks that are coming up on Gen AI enabled systems that have an exposure to non-enterprise users, to people outside. There was some example that kind of went a little viral where somebody uh, tweaked or prompted a chatbot selling cars, or rather, kind of answering questions about sales at a car dealership to offer them a car at an extremely low price. And the reason why that happened is essentially, um, there weren't the right kind of safeguards in taking the raw output from Gen AI and pushing it out to the actual serving end on the outside of the chatbot. So going forward, we will probably um, see these things evolve from just depending on purely LLMs to be self-sufficient in being able to produce kind of compliant outputs, and go into kind of multi-agent systems, multi endpoint systems, put together with agentic frameworks, where there would be kind of endpoints that would check the output going out, or there would be post-processing code that would post-process the output and make sure that they sit within the bounds of the sets of output that are allowed to go out, and so on and so forth. So that's another thing that can let us say, in the short term, take a little while to mature before really sensitive industries adopt them as systems that are externally exposed. But I don't consider them as a permanent roadblock. It's not a cost. It's not a permanent flaw. It will get over with. Other kind of kind of enterprise hesitations, etc., is of course that generative AI models are by and large opaque, whether they're open source or closed source. If you ask anybody why are they exhibiting emergent properties, I don't think anybody can actually explain it. Systems that are designed to essentially predict the next token, how come they show quote unquote intelligence? So there's in many industries where reliability of the output is important as opposed to creativity, there would probably be more hesitation. Well, there will probably be less hesitation in industries where creativity can have a little bit of leeway. Things like generating newspaper articles, or generating videos, generating pictures that go on an ad, or those kind of things. So they'll probably adopt faster than, I don't know. I think it'll be a little while before we see a Gen AI robot run a nuclear power plant, let us say. So yeah.
I mean, that's a very, what you say, interesting use case about the nuclear power plant. I mean, we can have a whole different debate on that. And if we ask people that, will you be, comfortable saying that an AI is operating a nuclear power plant, then that itself is, what you say, another topic for a podcast that we can have, actually. Yes. So, coming to some different facades now of costing, so, and everybody is interested in keeping the costs at reasonable level. So if you ask the tech guys, they would say we don't care about the cost, but then at the end of the day, the enterprise has to run. So,
Mhm.
the production cost of some of the AI models can be high at scale. Is what you say the perception with lot of what you say implementations currently. So, do you think how do you see that perception, and do you think that from an adoption perspective, that will be what you say not as a roadblock, but as one of the things that would be closely monitored, and how can we make if that is a point, and how can we make accessible and cost effective adoptions for these models?
Mhm. So, cost is always important. The thing to remember though is that we are ultimately talking about compute costs, right? And compute costs do follow Moore's law. If you think about how the price points were when let us say GPT 3.5 Turbo first came out versus what its price point is today. I remember the numbers right off the top of my head, but I believe it more or less fell. In fact, it actually fell faster than the 2x per 18-month law of Moore's law, right? It actually fell faster than that. Now, no, no, no. That said, it's still a non-trivial element. I mean, ultimate. So the way to think about cost is at the same time important and at the same time something that you want to be a little forward thinking about. So unit cost is always important. You do not want to make an overly costly, overly complicated system that is bringing a productivity lift or any other kind of lift that is a fraction of the cost of serving it, right? So start with your unit cost calculation, and have all the right numbers to have at least a justification that, oh, when this scales, this is what we're looking at in terms of the revenue versus cost, the ROI itself, right? And then give yourself some leeway in projecting out how the serving cost of the systems are going to go down over time, because they will go down over
They
time.
will go down. Yes.
Moore's law of parks, right? And also it's not just Moore's law, by the way. It's also architecture. If you design your system from the get-go, where you can swap models in and out, as and when model architectures get better, as and when you can have there are smaller models that are more fine-tuned for your purposes and so on and so forth, you can probably bring down that unit cost further. So you have to take a little bit of a leap of faith that that cost next year, next to next year, etc., are going to be vastly lower compared to what it is now. While at the same time, it the unit cost at least has to be at a point where the ROI makes sense in an order of magnitude. So that's how I'd put it. And the other little thing is while there's non-trivial amount of NRE that goes into building these models, you'd also want to make sure that you're dealing with use cases that are not so rare that they would not get amortized out. And finally, especially if you're going into fine-tuned models, which most likely quite a large number of future systems are going to go into, you want to also think of your total training costs. And by what I mean by total training costs is not just what it takes to run the GPUs to fine-tune your model, but also how you acquire training data, how you process training data, how you pipeline it, and then how you train it.
Right. So I think the key takeaways here, which I could gather, is unit costs. It's something you should always be looking at, and are functions of the business use case you are trying to build. So that is one thing. Second thing is there always be a cost arbitrage when you would try to like roll out or scale out based upon what exactly you are trying to build. Like you said, swapping the models in and out. And the third thing, probably you are looking at it how you are wiring the system when you are building it from a scale perspective. So I think this was very handful and useful for that. So now coming to the next thing is sometimes AI is perceived as that magic wand, and we say that that if we apply it here or if we apply it there, we may get good results. But there is always what you say a conditions apply asterisks to it, that both the consumers and organizations need to understand the capabilities and limitations, and where rightly to apply it and where no, even in cases not to apply it. So there is this literacy component. Then we talk about and we say that there needs to be AI literacy to bridge this gap of perception and reality, particularly when it comes to complex concepts like prompt engineering. So imagine that you talked about during our strategy discussion, that you said that one of the things that enterprises can look for is identify the business use cases, identify the tools, and they can enable the users to really make use of Gen AI from a productivity perspective. So here then, but if we are looking at conversational use cases, then prompt engineering is something that comes into picture. But that how will the enterprise then do the literacy about prompt engineering? So I just wanted to have your views on that from a literacy versus the perception and reality front.
Right. I've seen this industry long enough that I remember that people used to be very skeptical about even straightforward machine learning use cases, and they used to think about, oh, this is a black box, let's stay away from it, right? And now the pendulum has swung completely the other way, where there are entire entire groups of people who are like true believers in AI, right? Who believe in the omniscience of AI, let us say. Truth is, the actual reality is somewhere in the middle. Yes, the pre-trained generative models with transformers inside, multiple layers, trained over multiple trillions of tokens of data, are probably as smart as at least the median human these days, or getting close to that. But at the same time, this is not magic; it's machine learning. And the first principle of machine learning is that as long as you're presenting it cases that are similar are in the same data domain as what you trained it with, then you would expect an answer that would have a reasonable level of accuracy. And things that are not going to. So this thing about AI is actually, in spite of all the advances that we have seen, these architectures are still far slower than humans in learning from new data. So I think Ian LeCun was the one who actually talked about it most, but I think people have observed it in general. So if you think about the total amount of data that was needed to train uh, models like GPT-4 or even open source models that are out there, um, let's say even text models. So the amount of text that was pumped in to train these models, it would take 20,000 years for a human to learn all those things,
Yes.
to read all those things.
Right.
But in order to speak, uh, in order to answer questions the way GPT-4 answers questions, we don't need to read for 20,000 years. So these systems are less efficient learners than we are. While on the other hand, you see, uh, young children just observing the world, right? And and you know and learning the rules of the world more or less fairly efficiently. It does not take them a heck lot of time to figure out, oh, gravity exists. If I drop this, it falls, right? But does AI learn that efficiently? It doesn't yet. No, there are different directions in which people are going, which is still experimental, right? Like for example, one thesis is, oh, let's train this with video rather than with text, and let's see what happens. Maybe that, but that's all in the future, right? So if you look at today's AI system, the key to understanding where the limitations lie is realizing that these systems learn slow. And when presented with novel cases, they are less likely to come up with answers that would be more obvious to humans as common sense answers. So that's the limitation. Now they do have an advantage, which is that, hey, they did train on 20,000 years worth of reading.
What the brain?
There isn't any single human being who has read everything that quote unquote read everything that OpenAI has, right? Or any other model has. So where you want to use these is where you would otherwise need a human to read through or listen or understand a whole lot of things in order to do that thing. So that's one. The other is where a trained human can still do it, but the type of use cases that are coming to it are fairly repetitive. And as a result, it's very unlikely that there would be use cases that fall outside the bounds of what an AI can actually handle. Great example is the fast food ordering example I gave, right?
Right.
You don't pull up to a restaurant window and ask about the meaning of life. So you ask about what food is on the menu and so forth. Now, so given the strengths and weaknesses of humans and AI, at least for some period of time, what I foresee as the most efficient use in real use cases are hybrid intelligence, where you would have AI handling most of the let us say predictable work, or most of the work that require going through large contexts of data, and then you would have humans to let us say step in where the AI fails. And of course, over time, that ratio is going to shift more and more and more towards AI's advantage, to at least get to a point where the AI makes less mistakes than just plain and simple human errors. And once we reach that point, then I think as a society and as individual use cases, as enterprises individually would need to start making decisions. What is the point when you want to turn off the human?
Right. I think that was so very elaborate with the examples that you talked about. I really liked the analogy when you said that you talked about the meaning of life thing. You are not gonna ask on that restaurant use case or on that mic thing where I can imagine somebody asking that, and that would be a very gross thing. So, but what happens is, I just want to expand that example which you gave. And, if this case happens, just for the sake of it, that if somebody comes in and asks for a meaning of life kind of a thing, just imagining that as we can imagine it, there would be a compliance which is going to govern the answer to this question, that it is not what you say far-fetched thing, or there has to be certain compliance which guides the answer then, and then tells the user maybe this is what, this is not a compliant question, or we are not from a compliance perspective we are not liable to answer this question, or there has to be some answer but from a compliance perspective that the person who is asking for the meaning of life at that wrong place standing at that burger joint is asking. So, what are the key considerations for the companies deploying and developing AI to ensure responsible, ethical use of this technology, and also how do you see the compliances affecting the development? Right, for example, recently we had the European Parliament and they came up with certain compliances that they want the AI system to adhere to. So what's your how do you see that
Yeah.
landscape?
So just to be clear, I wouldn't necessarily call that an example, a compliance example. It's more of a use case design example, right? So that's why what I mentioned earlier, that you don't really want to design a system where the LLM output is the final thing that goes out to the outside world. You want to ensure that the way you have designed the system, that the answers that are going out fall within the bounds of what needs to fall. That's number one. That's how you design in your use case design. You ensure that the conversations and the output stay within the bounds that you need the use case to stay within. The second thing is, like I mentioned, that for some time to come, hybrid intelligence will be there. There will be some out of the blue use cases which will need a human fallback.
Right.
And sometimes they're probably not going to be important enough that human fallback is needed. Where where it's, let us say, not mission critical. But in things that are mission critical, for some time to come, hybrid AI is here to stay. So that's not exactly a compliance concern. Now, as far as regulations on AI and compliance and all that, uh, I mean, I think it's very premature for us to try and regulate an industry that is still growing, and we need to be very careful to not try and overly constrain this new engine of human development and societal improvement. And this is a new economic engine that we are creating. And let's just say I'm glad I'm not in Europe. Okay. I have seen those draft rules. I hope they uh, don't do the maximal impact of what they're trying to do. But I kind of remember. I mean, maybe I'm revealing my age here, but I kind of remember, back in the late 80s or so, there were similar concerns about, oh, if we let computers to do things like calculating the whatever total amount in the banking transaction, etc., it's going to lead to so many jobs getting lost.
Right.
And there were actually parts of the world where they said that, hey, we don't want computers here. This tech phobia that is driving the mission to regulate AI, it feels like a deja vu. And make no mistake, in the world there will be winners and losers based on who adopts tech and who does not adopt tech. Europe made its decision or is in the process of making its decision. Let them. But we need to be very, very careful about not over-regulating this industry. At the end of the day, there are other things in place where if a if an enterprise or if any individual for that matter does something that is illegal, that is unethical, there already are laws in place for that. In many ways, code is also speech, right? So if speech is free, code should be, the world should let code happen the way code happens. If it causes damage, then there are other pieces of already existing regulation for protecting us from that damage. So unless there are some extremely clear examples where you need to regulate the AI piece rather than the business as itself. I don't see why people should pick on a particular way of solving a problem and say no, go do it the other way. For example, okay, if an AI system deployed in the airplane crashes an airplane, then you can always go and ask for damages from the airplane company, saying, hey, your airplane crashed. But you should not say that, oh, because you have an AI piece in an airplane as opposed to a deterministic piece of software, that is the reason why we cannot let you do it this way. Because it's not obvious to me that a system without AI will not fail. It does. I mean, there are plenty of examples, right? So the AI paranoia that is a driving regulation. We need to make sure that as a society we let technology evolve and not squelch it before it had a chance to evolve, to mature, and get adopted in the right way, and let the kind of laws of economics drive it rather than regulators trying to be smarter by 10 steps ahead of the AI while they themselves don't know what AI will evolve into.
Yes, I think in this answer I could clearly see the passionate technologist in you, speaking and mentioning the points. So now coming to the next one, which domains or industries do you believe will be most significantly affected by the advancements in Gen AI or AI technologies in coming years, and how do you see the spectrum being blown out?
Yeah. So couple of things are, I think, already being ahead of the curve in adopting AI. So one is anything that where the jobs involved are relatively repetitive and hence can be more easily adopted to a properly designed AI system. Um, the other are things where I wouldn't say accuracy doesn't matter, but let us say there isn't necessarily a right answer, and hence uh, there isn't a very hard need for things to come out a particular way, and those tend to be industries that have more open-ended creative components to it. So things like design industries, creative design industries, writing writing descriptive documents or creating images and videos that are supposed to kind of follow a theme and create something that is prompted to, but does not necessarily have a right output that people are looking for. Um, um, and then the third thing is uh, most likely there would be a whole lot of other industries like financial industries, for example, where you will probably see a lot of kind of AI under the hood application, where they're not necessarily AI systems that are directly interfacing with the customers, but they are making these industries far more efficient and, in a sense, more accurate in making their decisions in how they are serving their customers. Because it can simply look across more data than a human can, and then come up with suggestions that are more thorough than a human can, and even put together all those repetitive tasks like generating documents, generating contracts, and so on and so forth. So fintech, legal tech, those areas are going to involve significant amounts of AI, with the caveat, like I mentioned, that in a lot of these cases, you may actually see the hybrid AI model, where the AI will be under the hood, while there will probably be some either programmatic shell or a human fallback in those cases where the AI output does not turn out right.
Right, right. But as you said, it's just the beginning, and we see a bright future ahead for the domains. I could clearly make out from that. So I think we are exhausted of the questions on the list, that I had for you. So we are really thankful, Debrag, that you spent your weekend, Saturday morning with us, with all these curious questions that we had for you. And thanks for sharing an AI practitioner's viewpoint on all these important subjects, be it about selecting how do we go about selecting the right use case, or how do we implement the Gen AI strategy, to looking at models, the costs, then also the compliance part that we talked about. Then you also mentioned about how what the three impactful use cases you could see in your journey. So we are really thankful for your time, and we hope to see you do more neural networking with Ketan, that is me, in the next coming episodes. And it would be very
That
interesting that after, let's say, 2 3 years, we are talking about the same things, but you may have a different perspective, a completely different perspective on all the things that we discussed. Thank you. Thank you.
Thank you, Ketan, and have a wonderful day.
Thank you. Thank you.